Hello everyone. From this video, we are going to start with the questions of variable size sliding window, and the first question which we are going to take is longest subarray of sum k. Now, first of all, how to identify that this question can be solved by sliding window. So what you need to do is you need to tell the size of the subarray, the maximum subarray, which has a sum equals to k. So first of all, we have got subarray, isn't it? Whenever we hear a word of like subarray, sliding window can be one of the approaches. Okay. So now, how to confirm that this question is a sliding window? First of all, one thing which you need to keep in mind is that the array elements are greater than equals to 0. That is, the array elements are not negative in this case. If it is negative in this case, it can't be solved by sliding window. Now, since the array elements are all greater than equals to 0, and when you suppose start from some index, you start taking the sum, like you take this number in the sum, you take this number, you take this number, you take this number, you take this number. And let's suppose at this point of time, your sum exceeds k. That is, your sum exceeds the maximum allowed value of sum. So what you will do? You will tell that, yeah, this window is not possible. So you need to like reduce the sum, isn't it? Now what you will do is you will just shift your index towards front till the value of sum is greater than k. Once you reach that sum is less than k or less than or equals to k, you can say, yeah, this window is valid. For example, if suppose you take, you have an array 1, 2, 4, 7, 2, 1, 3, 4. Let's suppose this is an array and you have a sum like, let's take this value as 6. Okay. And now you have a sum that is maximum allowed sum as, let's suppose, take it 7. Okay. So what you can do is you will start from here and you will just keep moving your this jth index, and you can just keep a sum which is initially 0. Now you take 1. When you take 1, you add 1 in it in your sum. Okay. Then you take 2. You shift your j over here, you take 2. Okay. You add it in your sum. You check the sum, it is 3 and it is still less than 7. Again, you come to like 4. You shift your j, you add 4. Again, your sum is less than equals to 7. It is valid. But once you shift your j over here, that is to 6, and take 6 in your sum, you will see that your sum exceeds the maximum permittable value, isn't it? So what you will do is you will just keep shifting your I until your sum is greater than 7. So once you shift your I from 1, you need to remove the contribution of 1. So you will just subtract 1. You shift your I over here. Now also sum is greater than 7. So you will not just shift your I one time. Like in fixed size sliding window, we only need to shift our I only one time, isn't it? But here, the window size is not fixed. We have some fixed condition. So what we need to do is we need to shift our I forward until the condition is not satisfied. So you will shift, like when you come to 2, and so you need to subtract 2 because the condition is still not satisfied, and you shift your I over here. Now still the sum is like equals to 10 and it is again greater than 7. So you need to shift your I over here and you need to subtract like 4 from there. Okay, so now your sum is equal to 6, which is a valid thing. Now every time when you come to this condition, like you have an I over here, j over here, and your like condition is getting satisfied. Like all the numbers from I to j, when we sum up those numbers, that sum is greater than less than equals to the maximum sum allowed. So every time what you will do, you will calculate the size of window and just maintain the max of this. Like you can maintain an answer which is initially equals to like 0. Initially you have a 0 size window, and every time when you have a valid window, you can do like answer is nothing but max of answer comma size of window at this time. So yeah, this is how we approach the question of like variable size sliding window. Like in this case, the window size is not fixed. Window size kuch bhi ho sakta hai. But one condition needs to be validated, that this sum cannot exceed the value of 7. Every time you get the value of sum less than 7, you can say, yeah, this is a valid window, and let's store its size or keep a maximum of all keep the maximum of sizes of all the valid windows. But if this is not the case, so you know that you have to reduce the time, like you need to reduce the size of the window, or you need to reduce the sum. For that, what you will do, you will shift your starting value until that condition does not get validated. So yeah, this is the approach we are going to follow in case of variable size sliding window. Variable size sliding window. You can clearly see how the size is variable because we are trying to like validate a condition instead of validating the size of the window, isn't it? So yeah, let's see the template of code. Like what is the code we are going to write in case of variable size sliding window. First of all, everyone got familiar. Everyone should get comfortable with how we can identify that this is a case of fixed size slide, a variable size sliding window. Let's say it was not like the array elements was between minus 10 power 9 to 10 power 9. That is, the array elements can be negative. Still, can you apply like this sliding window approach? Let's see. Let's suppose we calculate some sum in this index, I to j, and let's suppose we have a sum, and this sum exceeds the value of k. So can we apply the sliding window over here? Sliding window कब apply कर सकते हैं? जब when we shift the value of I, this sum should decrease, isn't it? मतलब once we shift our value of I and we reduce the contribution of like remove the contribution of this number, this value of sum should decrease. Now, how many times we need to shift the I? That is different case. But every time we shift, the value of sum should decrease. But let's suppose we have a number something like this, minus 1, 2, 4, 6. And let's suppose the maximum sum allowed was 7. Okay. And we have some numbers over here. So once we start taking the sum, like keep our I over here, j over here. Both are initially 0. And initially the value of sum is 0. Now when we came to j, we took its contribution, the sum became minus 1. And we shifted our j over here. And still the sum is less than 7, so it is a valid window. Now when we come to j, we take its contribution. We see that the sum is equals to 1, still it is valid, so we just shift our j. When we come to 4, we take its contribution. The sum is equals to 5, still less than 7, so we tell yeah, this is possible. Now when we come to 6 and take its contribution, the value of sum is equals to 11, which is greater than 7, isn't it? So in this case, what we want is whenever we want that we lessen the size of window so that the sum gets decreased. But when we shift our I from 0 to 2 and remove its contribution, like when we do 11 minus minus 1, the value of sum increases. So if this is the case, then we are in a big trouble, isn't it? Like window size kam kar rahe and sum बढ़ रहा है. We are decreasing the size of window and the value of sum is increasing. So that question cannot be handled by like sliding window. That question can be solved by using math, which is like different part. This is not in our like scope for today. For today, we are just studying sliding window. So for sliding window, what should happen is, let's suppose this window is not validating the condition. So whenever you shift your I, that shifting of I should contribute towards your condition to be validated. Like you want your sum is greater than the maximum permissible value, isn't it? So whenever you are shifting your I, जब भी आप I को shift कर रहे हो आगे, so always the value of sum should decrease so that at some point of time you get the condition that sum is less than equals to k. This is a valid condition, isn't it? So if you are shifting your I and your value of sum is increasing, then that is not the question of sliding window, isn't it? So yeah, this is why at the starting I gave that array of I is greater than equals to 0, which is like nice to have. Okay. So now let's see the template of the code for the variable size sliding window. Always you are going to follow this template. What you will do is you will initialize your I to 0, your j to 0. And let's suppose for this template, I am taking this question as my template, but you can apply anything. Like in this question, we need to apply sum, isn't it? So initially I am taking sum as 0 because initial value is sum is 0. So now what is the maximum value that j can go? And we need to also keep the size of answer. Like initially the value of answer is 0 because initially we have not taken any window. So window size is 0. Now the value of j can maximum go to index n minus 1, that is to the end of the array. So we will keep a check like while j is less than n, and we will just add the contribution of this jth element. Now once we are done with it, we will just check the condition that we will just check if the condition is not validated. Like in this case, we will check that if sum is greater than the maximum allowed sum. If this is the case, so why? Just tell me one thing, how many times we can shift our I? Like let's suppose our I is over here and our j is over here. So we need to shift our I if the condition is not validated. Let's we shift our I over here, then over here, then over here, then over here. Can we shift our I like to here? Like can we do that? Or can we shift our I over here? Just tell me. Like if we shift our I, our j is over here and I is over here. What does this mean? That their window size is 1. Now when you shift your I over here, let's suppose your I comes over here. This means that your window size is 0, isn't it? Your window size is 0 if I is greater than j, isn't it? Now when you shift your I over here, your window size becomes -1. Is it possible? Like can your window size decrease? Like if you try to understand in more simpler way, when you came from like this I to j, you took the contribution of all the numbers till j, isn't it? Till j, you took contribution of the numbers. Now, while you are shifting your I, you can't remove the contribution of the number whose contribution you have not taken till now. मतलब हम लोग j तक नंबर तक का कंट्रीब्यूशन लिए थे ना, उससे आगे का नंबर तक का कंट्रीब्यूशन तो अभी तक लिए ही नहीं है. So if we shift our I, like we can remove the contribution of this number when our I is over here and shift our I over here. But once we remove the contribution of this number, then it's a blunder, isn't it? Because we haven't taken the contribution of this number till now. So that's a blunder. So just tell me that if sum is greater than k, then till where we can run our while loop? We can run our while loop till the value of I is less than equals to j, isn't it? Like उससे ज़्यादा तो I का value नहीं हो सकता ना, because we can't remove the contribution of the number we haven't taken till now. So yeah, while I is less than equals to j and the value of, like for in this case, the value of sum is greater than k. Till this is the case, we will shift our I. In the case of fixed size sliding window, what we were doing is we were just validating the size of the window. In this case, we are validating a condition. Okay. So when we are in I, we need to remove the contribution of I. So what we will do is sum minus equal num like array of I, and we need to shift our I. Okay. So after doing this, we will just keep a check. Like if even after doing this, we have a value of sum which is less than equals to k. If this is the case, we will just store it in our answer. Like we know that from I to j, we have the size of window as j minus I plus 1. So answer is nothing but max of answer, comma, the present size of window. Because we need the maximum size of window which satisfies this condition, isn't it? So we need to store the size of each window and just take the max of it. So answer is max of answer, comma, j minus I plus 1. Okay. So once we are done with it, we need to see out our answer. Like this is our answer, isn't it? Okay. So this is a template which we are going to follow in case of fixed size sliding window. Yeah, I missed one thing. If you all have seen, I have not incremented my j. So every time when we come to 1j, we need to shift our j for the next iteration, isn't it? So just we can keep over here j plus plus. Okay. So yeah, this is the like case. Let's code it down once. Okay, so what we can do is, let's suppose we take the size of the array. Let's take the input in this array. Okay, we have took the input. Now what we need to do is we need to like keep one answer which is initially 0. Like 0 is the size of initial window. We need to keep initialize our I to 0 and j to 0. And yeah, till now we have a sum of 0. So that also we need to keep. Now what we can do is the maximum value of j can go to n minus 1. So we keep a while, we will run our while loop till j is less than n. We will take the contribution of the present jth number. So yeah, sum plus equals the array of j. Now what we can do is we will keep a check that while, like if the value of sum we found till now is greater than the maximum permissible value. We can take the input of maximum permissible value over here. So if sum is greater than k, so how many times we need to shift our I? We don't know that. We don't know that how many times we need to shift our I. Just keep in mind. In case of fixed size sliding window, we knew that only shifting I one times, we can validate the size of window. But in this case, we don't know after shifting how many times of I, we will validate our condition. So we just need to shift our keep our check till the maximum value of I we can shift. We can shift our I only till I is less than equals to j, because we can't remove the contribution of a number who hasn't contributed till now, isn't it? So yeah, while I is less than equals to j, and what is for conditional validation, we can keep a check that we keep shifting our I till the value of sum is greater than the maximum permissible value. So once we are in I, we will remove this contribution, sum minus equal array of I, and we will increment our I. Once we are done with this, so we will just keep a check that after doing this, if we have a sum greater than like less than equals to k, so answer will be nothing but max of answer comma j minus I plus 1. And yeah, we will shift our j. Once we are done with it, we will just print our answer. So yeah, this is the code. Let's try to run it for one of the test cases. Let's suppose the size of array is 5 and the value of k is like maximum sum allowed is 6. And let's take the array of array elements as 1, 2. Let's take it as 3. Let's take it as 6. And let's take it as like 2. Run it. We got our output as 3 since this is the window of maximum size where the sum is equals to 6. We also had sum 6 over here, but this will not take this because it is of window size 1. Okay. So this is the code. I hope you all are very much comfortable now with the variable size sliding window, and you are very much comfortable in knowing the difference of fixed size sliding window and variable size sliding window. Like in fixed size, there is a fixed size of a window, and in variable size, there is some fixed condition which needs to be validated. Okay. So yeah, this is the concept. We will do practice some more questions of variable size sliding window, and you all will get more comfortable with it. Okay, for now, let's stop it over here. Thank you.